Imagine trying to code an entire game using only zeros and ones. No Java, no Python, no JavaScript. Just binary. Every instruction, every command is binary. This is how programming was. But somehow humans managed to turn this nightmare into high-level programming languages today. And this is a story of how humans understood to talk to computers. Computers are not smart. They don't understand English, they don't understand words, they don't even understand numbers the way we do. They just understand only one thing, that is electricity, on and off, that is zeros and ones. Everything your computer has ever done, every game, every website, every AI model, eventually becomes billions of tiny electrical signals. Early computers in the 1940s were enormous machines filled with vacuum tubes. They consumed huge amounts of power, generated massive heat, and were unbelievably difficult to program. Because to control them, humans had to communicate directly to them. This was called machine language, the first true programming languages. Imagine writing instructions like this. It barely felt like a language because it consists only of ones and zeros. If you want to add two numbers, just binary. If you want to move a data, just binary. If you want to do more operations, just perform more binary operations. To humans, this looks impossible to read, but to a computer, this was understandable. Every operation required binary instructions. One tiny mistake could break the entire program. Programmers spent hours and hours debugging single lines of code just to find which one suits perfectly well. And programs are often physically written on a punch card. Imagine dropping them on the floor. The entire program could be destroyed at a single moment. So computers are powerful, but humans needed a better way to communicate to the computers. Then came a revolutionary idea. Instead of writing those binaries, humans could write those short words like this: MOV A,5, add A,5. This is called assembly level languages. These instructions were easier for humans to remember. This new system became as the assembly language, but computers still don't understand English like commands. So humans built another program called assembler. The assembler acted like a translator. Human-readable instructions went in, machine code came out, and for the first time in history, programming felt slightly easier. But there was a massive issue. Every computer had different softwares. A program written for one software runs only on that. It cannot be run on another machine. So programmers needed to create softwares again and again, trying to make them work. And as computers became more advanced, software became larger, more complex. It seemed impossible to manage. Humanity needed something more advanced to communicate with the computers. They needed a universal bridge between humans and the computers. In the 1950s, computer scientists began asking a dangerous question. What if programming looked more like human language? The idea changed history forever. One of the earliest breakthroughs was FORTRAN, short form of formula translation. It allowed programmers to write mathematical instructions far more easily. Then came COBOL, designed for businesses and finance, led in part by computer scientist Grace Hopper. She believed programming should be closer to English. Many people thought this idea was ridiculous, as they thought computers were super powerful and it should not be done by making them understand languages like English. We humans should adapt to their languages and we should process only in zeros and ones to avoid wasting the superior power of computers. But exactly that is what happening nowadays. We just write in our own language and the code is being generated. And the starting point for all those things came here. And slowly, they were right. Compilers were invented, programs that translated high-level code into machine code automatically. Humans could finally focus on solving problems rather than understanding those binaries and writing large sequences of ones and zeros. Then came explosion of programming languages. C gave programmers the speed and reliability. C++ was super quick and it introduced the object-oriented programming stuff. Java promised, write once and run anywhere. So JavaScript transformed the internet and Python literally made programming languages like a pseudocode. Just write as you do in a pseudocode and just compile it. Every language was invented to solve a problem. Speed, simplicity, portability, security, web development, artificial intelligence. Programming languages weren't competing randomly. They were just evolving just like the human language. Today, humans no longer communicate with computers with just binary. We communicate using layers upon layers of abstraction. Modern programming languages are so advanced that some developers barely think about the hardware underneath. And now AI has changed the programming completely. That we could just use a regional language and talk to the AI. It just gives a prompt and we could use it to generate any sort of complex projects. Our original dream as written, that we should think in our own language and the program should be executed. That's what exactly happening nowadays. Now it's almost complete that computers understand humans naturally. From punch cards to Python, machine code to artificial intelligence, programming languages are more than tools. They are humanity's attempt to communicate with computers, and the conversation is only getting started. If you enjoyed the story, don't forget to hit the like button and stay tuned for more programming and technology related videos and to find the hidden secrets behind the modern technologies. And comment below what programming language you consider has changed the history the most. Thank you for watching.